Okay, the Ministry of Education's activities on their website. This is mathematics for year 5. So I've written up there mathematics activities for year 5 for term 1 of this year, 2020. And activity 9, which is division of 4 and 5-digit numbers. I've written up the 6 problems, the 6 long division problems that they have, well, division problems that they have on the activity sheets online. So I thought I'd help you solve these, show you how we go about solving these in an easy way that you can apply to any division problem. And so the 6 are up there. If you already have the worksheets, that's fantastic. Now to help us illustrate the different points in solving these, I've also prepared the multiplication tables. Of course, you can say them in your head, but this is just makes it easy to illustrate what I'm saying. So for the first one, I have the 4 times table here, right? Just to make it simpler for you. Okay, so first one we will do on the board is number 1, which is 4, 3, 5, 4, 2 here. So it's 3,542. Write it a bit clearer. Divide by 4. Okay, if you've watched the last 2 videos, now we first look at this first digit here, which is a 3. Can 4 go into 3? No. 4 is too big, or 3 is too little. So we look at these 2 digits, 35. Can 4 go into 35? Yes. How many times? We want the biggest number that we can get, which is just under 35. So if we look at the 4 times table here, look for the number which is just under 35, but not over. So here you get 4 8s. Huh? 8 4s are 32. There you go. 8, 32. So 8 times 4 is 32. However, this 32, you want to make it into 4 digits, so you just add 2 digits there. And same thing with this 8 on the side. So 4 times 800 is 3,200. You subtract that from the 3542. 2 minus 0 is 2. 4 minus 0 is 4. 5 minus 2 is 3. And 3, 3, 0. 3 minus 3, 0. Now, do the same thing over here. Now, can't go just as we did with the top one. 4 can't go into the 3, but it can go into the 34 if we take the first 2 digits, 34. Again, looking at the 4 times table here, 8 4s are 32, or 4 8s are 32. So again, we'll put 32 there and 8 here. 4 times 8, 32. Here we need to make it 3 digits, add a 0 there, and do the same thing on this side, add another 0. Okay, subtract 320 from the number above. 2 minus 0 is 2. 4 minus 2 is 2. Left with 22. Okay, carry on. 4 times what is a number close to 22? Because 4 can't go into 2, so we're looking at both digits, right? 22. Again, to the 4 times table. 4 5s are 20. We can't use 4 6 because that's 24. Okay? 6 4 is 24. Too big. It's bigger than 22. So we'll go 5 4s are 20. 4 times 5 is equal to 20. No need to add any more zeros here because 2 digits on top, 2 digits on the bottom. Fine. 2 minus 0 is 2. Can 4 go into 2? No, you can't. Too little. The number 2 is too little. Okay, so now you know you have a remainder of 2. You add down this, 885. 8, 8, 5. Ones column, tens column, hundreds column. I haven't really put it in its proper columns. But if you add it down, 885. So your answer is 8, 8, 5, remainder 2. So I'll put the answer up here. 8, 8, 5, remainder 2. Okay? Okay, now that we need to go on to the second one. I'll erase this. Take down this 4 times table. Now the second problem is dividing by 20. I have prepared 20 times table here. Now, I know that in school we don't do 20 times table. We go from 1 to 12, right? But I want to show you something. If you compare the 2 times table over here and the 20 times table, you'll find that the only difference is that in the 20 times table there's an extra 0. Right? So 20 times 1 is 20, 2 times 1 is 2. All you need to get from this to here is adding an extra 0. So if, say, you want to say 20 times 10, don't need to think about 20 times 10. Say 2 times 10, 2 tens are 20. If it's 20 times 10, it's just an extra 0. So 2 times 10 is 20. 20 times 10, extra 0 is 200. It's an easy way for you to link between the two. So you don't really need to think in terms of 20 times table, just think in terms of 2 times table. And then add an extra 0 onto the answer. Okay? I hope that helps. Now, on to solve the second one. 12, 8, 3, 5 divide by 20. Now the number 20, can it fit into 1? No. Can it fit into 12? No. So we're going to have to go for 3 digits. Here. It can fit into 128. Yes. How many times? Let's see how many times it can fit in to get a number just under 128. We're in luck, 120. So 20 times 6, 120. 20 times 6 is 120. Like I said before, you can think of it in terms of a 2 times table. So if you're looking at 128, you can simplify it by 1 digit. Look at it in terms of 12. And this number in terms of 2. So 2 into 12, 6. You end up at the same spot here, 6. So 2 times 6 is 120. That's after you add the extra 0, right? So 2 times 6 is 12. 20 times 6, 120. Now we need to make this 5 digits, just like the 5 digits on top. So add, we already got 3, we just add another 2 zeros and do the same thing on this side. So now you got 20 times 600 is 12,000, sorry. 5 minus 0 is 5, 3 minus 0 is 3, 8 minus 0 is 8. Okay. Does 20 go into 8? No, it doesn't. Does 20 go into 83? Yes, it does. Okay. 1, 2, 3. 83. So 20 times 4. 20 times 4 is 80. 20 times 4 is 80, right? Now we need to make this 3 digits. Add a 0 here. Do the same thing over here. Okay. If we're subtracting that, 5 minus 0 is 0, and 3 minus 0 is 3. Again, 20 into 3, can't do it, too small. 20 into 35, yes, can go one time. That's very easy. See, twice gives you 40, so that's a number that's bigger than 35. So the only one you can use is 20. So once to give you 20. Don't need to put any extra zeros here because 2 digits there, 2 digits there. You're set. 5 minus 0, 5. 3 minus 2, 1. How many times will 15 go into 5? It can't. So that becomes your remainder. 600 plus 40 plus 1. 641. So there's your answer. 641, remainder 15. 641, remainder 15. How many times does 20 go into 12,835? 641, remainder 15. I'll write the answer up here. 641, remainder 15. And that's the second one. We've finished with number 2 and on to number 3 now. I've put up the 5 times table to help you figure out which numbers to use when you're solving the problem. Number 3, 5. This number is what you're dividing by 5. 7,654. Can 5 go into 7? Yes. One time. That's fairly easy. 5 ones are 5. Yes. 5. 1. Okay. 4 digits on the top. We need to make the bottom 4 digits as well. 1, 2, 3 zeros on this side as well. 5 times 1,000, 5,000. 4 subtract 0, 4. Left with 5. Here you're left with 6. And here you're left with 2. Can 5 go into 2? No, it can't. Can 5 go into 26? Yes, it can. What's the number that's just under 26? 25. Right? On the 5 times table. 5 5s are 25. So 5 5s, 25. Make it 4 digits. Make it another 2 zeros on this side, just like we've done over here. Subtract this. 4 left over, 5 left over, 1 left over. Right? So now you're dealing with much reduced number, 154. Can 5 go into 1? No, it can't. Can 5 go into 15? Yes, it can. 5 3s are 15. So 5 3 is 15. 3 digits on top, only 2 here. Make it 3. Add the 0 on this side as well. Subtract that, you're left with 4. Can 5 go into 4? No, you can't. So you know now this is the remainder. Add 1,000 to 530. 1,530. Your answer to the question of 7,654 divided by 5. Answer is 1530 with a remainder of 4. And we'll write the answer up here too. 1530, remainder 4. Okay? On to the next one. On to question number 4. And question number 4, we're dealing with divide by 10. Yeah. Right? 2,160 divided by 10. 2,160 divided by 10. Okay. I've got the 10 times table here. But you can just like I pointed out before when we were doing number 2, where we were doing divide by 20, I was pointing out that the 2 times table and 20 times table, very, very similar. All the answers just get an additional 0 added to it. And I just wanted to point out the same thing here too. Even though the 10 times table is fairly simple, you have to remember that all it is the 1 times table, but with a 0 added to the answer. See, 1 times 12 is 12. 10 times 12 is 120. All that's different between this answer and this answer is extra 0. This answer and this answer is an extra 0. See? This answer and this answer, extra 0. So whenever someone says to you 10 times 11, just think 1 times 11 is 11, plus an extra 0, so 110. Or someone says 10 times 5. Think, okay, 10 times 5, but that's similar to 1 times 5, which is 5, and then just add an extra 0. So this same pattern, I just wanted to show you the pattern because the pattern cuts down your time in solving things. With maths, it's all about patterns. Once you find the pattern, it cuts down your time in solving things. It just helps you get from one point to the next point a little bit faster. Okay, now take away the 1 times table. Just put up 10. Okay. Right. So first step, 10. Does 10 go into 2? No, it doesn't go into 2. 2 is too small. Maybe we can use 2 digits, the 2 and the 1. Does 10 go into 21? Yes. Let's see which one is closest to 21, but still slightly under. 10, yes, but 20 is even closer, right? 10 times 2. Okay, 10 times 2 gives 20. 10 times 2 gives 20. We need an extra 2 digits here, because up here we have 4 digits. Here we only have 2. Extra 2 digits. And same thing here, extra 2 digits. Same number zeros here as here. That we add on, not same number in total, same number that we add on. Okay, so now we subtract the second line, so we end up with 160. So 0 minus 0, 0, 6 minus 0, 6, 1 minus 0, 1. Okay, next one. Does 10 go into 1? No, it doesn't. Does 10 go into 16? Yes. I can do this in one shot, but let's break it down just 2 digits at a time. 10 goes into 16 how many times? Once. 10. 10 ones are 10, right? 10 ones are 10. Need to add another digit there to make it 3 digits, so it matches the top. Add the same, add another 0, do the same thing. What remains when you minus that 100 is 60. Do the same exercise. Does 10 go into 6? No, it doesn't. Does 10 go into 60? Yes, it does. 60. 6 times. Okay, 10 times 6 is 60. 10 times 6 is equal to 60. 60 minus 60 is 0, so there's nothing remaining. 200 plus 10 plus 6. Add it all up. 216. So the answer is 216, and there's nothing remaining, so no remainder. And we'll write the answer up here too. 216. Yes? Now, if you look at that problem, this problem, the very simple simple way to arrive at the answer to is any number, if you divide it by 10, all you do is take a 0 off. So that's a quick way to check you arrived at the correct answer. Any number, you divide it by 10, you take off the last 0. That's if it has a 0 on the end. So just along the same lines, say 2,000 divide by 10. Instead of going through this, all you can do, answer will be 2,000 plus with, but minus 110. So it will be 200. 200. Or say 3,600 or 3,600 divided by 10. What will the answer be? It's the same as 36, but with 3600, but 10 less. So 360. Answer is 360. I'm just showing you. So we followed the same methodology here to arrive at the answer as we followed in 1, 2, and 3. I just wanted to keep the method the same, so you always know how to arrive at the answer using the same method. But shortcut, if you divide any number by 10, you're always going to get the answer with just 1 0 less. That's if it ends with the 0. Once you get into decimal places, then we can show you how you can arrive at the answer. But if you don't have a 0 on the end of the number that you're trying to divide by 10. Okay, on to the next one. Okay, on to number 5. And the problem is 9,582 divided by 8, which I've written up here. Okay. Now, I've also put up the 8 times table here, just to help us speed the getting at the answer along and help us identify exactly why we choose certain numbers. Okay, so we start off. Does 8 go into 9? Yes, it does. Goes in 1 time. 8 ones are 8, right? 8 twos are 16. 16 is already way over 9. So we choose 1. 8 ones are 8. Okay. Make it 4 digits. Add 3 zeros. Same thing over this side. Add 3 zeros. 8 times 1,000 equals 8,000. 2 minus 0. Subtract that. 2, 8, 5, 1. Does 8 go into 1? No, it doesn't. Does 8 go into 15? Yes, it does. Once. Because 8 twos are 16, so over 15. So 1, 8 ones are 8, right? Here we add another 2 zeros. We're not going to make it 3 zeros because if we add 3 zeros, it makes it 8,000, which is bigger than the number on top. The number we're doing 8 under the 15, right? The number here has to be less than this number in order for this to work. 2 zeros we've added, add 2 zeros on this side. So subtract that. 2, 8, 15 minus 8 is 7. Okay, 7, 8, 2. 8 go into 7? No, it doesn't. Does 8 go into 78? Let's look for a number here close to 78, but just under, and we come to 72. So 8, 8, 64, 8 nines are 72. 8 nines are 72, right there. 8 nines, so 8 times 9, 72. Put an extra 0 to make it 3 digits. Put an extra 0 here. You subtract that line. 2 minus 0 is 2. 8 minus 2 is 6. 62 left. Okay, nearing the end. 8 times what is close to 62? Yes. If we go down, 8 8 is 64. That's a bit too much. So it has to be 7 eighths. So 8 times 7 is 56. 7 eighths are 56. Minus. So here we will reduce that to 5. Take 1 to over there. 12 minus 6 is 6. Still with me? Right? 62 minus 56 is equal to 6. Can 8 go into 6? No, it can't. 6 is too small. So this becomes your remainder. And if you add here 1,000 plus 100 plus 90 plus 7, 1,197. Answer is 1,197, remainder 8. All right. Okay, on to the next one. Okay, we're on to our sixth and our last one, and it is 32,473 divided by 30. I've got up here multiplication 30 times table. And you're thinking, we never do 30 times table in school. That's true, but you do 3 times table. So I've got the 3 times table here, and just like I did before with the 1 times table and the 2 times table, there's a relationship between the 3 times table and the 30 times table, and all it is the answers just all get 0, 1 0 added to the end. 3 ones are 3, 30 times 1s are 30. 3 add a 0 becomes 30. 6 add a 0 becomes 60. 36 add a 0 becomes 360. 3 tens. 3 tens is 30. 30 times 10, add a 0, 300. 30 to 300. Just add an extra 0. Okay, so I've put 30 times table here just to help you arrive at the answer faster. Using our same method. Can 30 go into 3? No, it can't. Too small. Can 30 go into 32? If we use these first 2 digits, 32. Yes, it can. Okay. How many times? Once, right? So 30 times 1 is 30. And add another 3 zeros. So that 5 digits on top, 5 digits at the bottom. Bottom number is still smaller. That's all fine, okay? Same thing on this side. Add 3 zeros. Right? So we got 1,000. 30 times 1,000 is equal to 30,000. Don't be worried about the numbers being very big. Process is exactly the same. You might just be adding more zeros on the end, but it's okay. All exactly the same amount of work. Okay, 32,473. You minus 30,000. What you're left with, 3,742. 2,473. Does 30 go into 2? No. Does 30 go into 24? No. Try for 3 digits. Does 30 go into 247? We've used 3 out of the 4 digits, right? Does 30 go into 247? Let's look here for something just under 247, and we get it there. 3, 8, 30 times 80. 30 times 8 is 240. So 30 times 8, 240. Add 1 0, so 4 on the top, 4 on the bottom. Bottom number is still smaller than the top number. Okay? Another 2 zeros on this side. Subtract 3, 7. 2473 minus 2400 is 73. We're close to the end now. Okay, 30. Does it go into 7? No. 7 is too small. Does it go into 73? Yes, it does. Let's find out how many times. 30, 60. 90 is too much. 60 is under. Okay, 30 times 2. 30 times 2 is 60. Subtract that. We're left with 3. 7 minus 6 is 1. 13. Can 30 go into 13? No, it can't. 13 is too small. So this becomes your remainder. Add this down. 1,802. 1,802. 1,802. So that's my answer. I'll write it up here. 1,802. Remainder. Don't forget the remainder of 13. And I'll put that same answer up here. 1,802. Remainder 13. Right, all 6 done.